The goal of every design is to eventually have it constructed, so it's important that your drawing be well documented. In this lesson we're going to explore AutoCAD's dimensioning tools. On my screen I have some simple geometry. Before I apply dimensions to this, let me mention that I have already created a layer for the dimensions, and I'm going to be dimensioning this geometry using default settings. You'll find the dimensioning tools in the annotation panel. If I open the menu, you can see there are several options. We'll create a linear dimension first. I'll launch the command, and then I'll grab the endpoints on either side of this chamfer. It's very important when you're creating dimensions to use object snaps. That's the only way to ensure that your dimensions are accurate. A linear dimension will give us the horizontal or vertical distance between our selected points. So if I pull up, you can see I'm getting the horizontal measurement. If I pull to the right, we see the vertical. I'm going to pull this up and click to place a dimension. Knowing what we know now, if we wanted to dimension the overall height of this part, we could launch the linear tool, grab the upper left endpoint, and then the endpoint right at the end of this fillet. I'll pull this over to the left and I'll click. Let's try another tool. I will open the menu, and this time we'll try an align dimension. With an aligned dimension, we'll get the true distance between two endpoints. If I select the same two endpoints started with and pull my dimension out, you can see that the measurement is parallel to this line. Thus, it's giving us the true measurement of that geometry. I'm going to go back to the menu and I'll select angular this time. To create an angular dimension, we can select one line and then another. Pull out the measurement and click to place it. I'm going to create another. Let's select this line and this line. Notice that if we stay to the inside of the angle, AutoCAD will dimension that. If I move to the outside, AutoCAD will dimension the opposite angle. If I move my cursor up or down, I can also dimension the supplementary angles. Let's dimension this circle. I'll go back to the menu and I'll select diameter this time. I will then select the circle and I'll pull the leader out and place it over here. To dimension a radius, it's the same workflow. I'll launch the radius tool and I'll select this fillet this time and I'll pull the dimension out and place it here. Now, how do we know if we should be using diameter or radius? Well, a good rule of thumb, if you're dimensioning a closed circle, you'll probably want to use diameter, and if you're dimensioning an arc, you'll probably want to use radius. Now that we have an idea of how the dimensioning tools work, let's try and use them in a practical example. If I pan the drawing over, we've got a small mechanical part. Let's try and document this geometry. I'm going to start by dimensioning the overall height. So I'll go back to the linear option. I'll grab this upper right endpoint and I'll dimension down to the endpoint of this fillet. Then I'll pull my dimension over to the right. I'll give myself enough room such that I could place some additional dimensions here if necessary. Now, let's identify the center of this circle. I'll go back to linear. I'll start from that same endpoint and I'll select the center of this circle and I'll pull my dimension over to the right. Now let's dimension the overall width of the part. We'll use linear again. I'll grab this rightmost endpoint and I'll come over. And you might think that we'd grab the midpoint or the quadrant here. Usually we don't dimension to a quadrant, so I'm going to grab the center of this circle. I will pull dimension up and place it here. Now, to ensure the contractor knows the overall length of the part, let's dimension this radius. I'll select the radius option. I'll click this arc and I'll place the call out. Now that we have the overall width defined, let's identify some of these additional points. I'm going to go back to linear and I'll dimension from the center of the circle to this upper left endpoint and we'll pull that out. I'll press the spacebar to go back into the linear tool. We'll start from the endpoint where we left off and go to the center of this circle, and I'm going to pull the dimension up and place it to the endpoint of the previous arrowhead. I'll press the spacebar again. We'll pick up from the center of the circle and I'll dimension to the endpoint of the chamfer, and I will place this at the endpoint of the previous arrowhead. Now, do we have to create the final dimension? No, I could add these three dimensions together and subtract them from the 6.55 to get this dimension. The trick to proper dimensioning is to document your part with as few measurements as possible. You want to avoid redundancy. I am going to add another horizontal measurement. Let's identify the distance between these two holes. I'll go back to linear. I'll grab the center of this circle and the center of this one, and I'll pull out the measurement. At this point, we've documented the top edge of the part. Let's identify this next edge down. We'll do that using a linear dimension. I'll grab this upper endpoint, and I'll grab the endpoint right below it, and I'll pull out the measurement. That gets us to this edge. I don't need a dimension to the next edge down because we could use the radial dimension to get there. Let's dimension the length of this line. Let's identify this endpoint. I'll relaunch the linear command. I will grab the center of this circle and this endpoint. And as I pull this down, notice how the dimension is sitting on top of the part. I'm going to press the escape key. I'll press the space bar to go back into the command, and I'm going to dimension it from the endpoint back to the center of the circle. See how that puts a number on the other side? Next, I'd like to identify this angle. We'll grab the angular tool. I'll click both of these lines, and instead of pulling my angle out on top of the other dimension, I'm going to dimension the supplementary angle instead. So we've documented the top of the part, the bottom of the part. We've identified this point and this angle. There is no dimension necessary for this point. Once again, that would be a redundancy. Let's go back. I'd like to dimension a radius now. We'll take care of this fillet. Next, we'll take care of the circle. That will be a diameter. I'll click the circle and place the dimension over here. As I look at this, I need one more angular dimension up here. I'll launch angular again. I'll select the chamfer edge and the top edge, and I'll create a supplementary measurement. We'll pan the drawing down. Finally, we'll dimension these two holes. Since they're closed circles, we're going to use the diameter option. I'll select the outermost hole first, and I'll pull out the dimension. Since these are both the same, instead of creating another callout, I'm going to double click on this dimension. It brings up the text editor. I will click my right arrow to move the cursor to the end of the dimension. I'll press enter, and I'll type 2 holes. When I'm finished, I'll click on screen to close the editor. At this point, I think we've fully documented this part. The best way to know if you have enough dimensions is to pan the drawing over and try and recreate the geometry from your measurements. If you're missing one, that's how you're going to find it. With a little practice using these tools, you can quickly transition your design from an idea into a constructed project.